Hello there. We are now seeing a particle is moving in a curvilinear motion. Right? To identify the velocity and acceleration of the particle, we are trying to use the two types of the concepts. One is going to be kinematics, second one is going to be the kinetics. In the kinematics, what will happen? We are going to be considering only the field parameters, but we never consider what is the cause for that motion. In the kinetics, we are going to be considering the force, mass as well as the acceleration. It means what is the cause for that motion also we are going to be considering. So here the curvilinear motion and kinematics. And in the last video lectures we have seen, we derived the few equations to identify the total velocity and the total acceleration of that particle. Right? So now we are going to solve one problem with that connection. The motion of a particle is described by the following equation. Can you see? The motion of a particle has described in x-axis as well as the y-axis. At the same time, it is also depends on the time. The two x as well as the y show the path traveled by the particle is rectangle hyperbola. Right? So while we are doing this one, we need to prove it. That is going to be the path, the curved path what we are saying, that's going to be rectangle hyperbola. And also we need to find velocity, acceleration of the particle at t is equal to 0. So then how we are going to be solving this part? So there we can see, and he has given the x as well as the y. So we need to prove first a rectangular hyperbola. So to prove this one rectangular hyperbola, so then what I am going to be doing, I am going to be multiplying this x component, x is equal to 2 into t plus 1 whole square, and similarly the y is equal to 2 into t plus 1 minus. If I am going to be multiplying x into y is equal to, so when I am going to be multiplying x into y, I am going to be getting 2 into t plus 1 whole square, right? And similarly this into 2 divided by t plus 1 whole square, because minus 2 we are going to be getting, that is going to be divided by. So then what happened, this component will going to be cancelled out. So the finally x is equal to 4 I am going to be getting. So hence it is proved that it is going to be a rectangular hyperbola path it is following. It means that the body is moving in a curved path. The curved path name is going to be your rectangular hyperbola path. So now we will try to find what is the velocity and the acceleration at t equal to 0. So now we are trying to find the velocity and acceleration at t equal to 0. For this one, the displacement, the time relation in x direction already has given that x is equal to 2 into t plus 1 to the power of square. So now what I am going to do, I want to find out the velocity in the x direction. So what we can do, as we know that this x is going to be, that depends on the time. So then I am going to taking dx by dt, that's equal to 2 is going to be the constant and this term is going to be u square. So that's going to be 2 into t plus 1. And the one derivation, t derivation is going to be the 1. So then the final equation from this one I am going to be writing 4 t plus 1. Right? So what is the meaning of dx by dt? As we know that the rate of change of displacement with respect to the time, so then we can say that is the velocity. That I am going to be writing vx is equal to at t equal to 0. So this is the condition we have. So then what I am going to be doing, I am going to be multiplying this one 4t plus 4. So then if I am going to be substituting t in this equation, then I am going to be getting 4 meters per second. So that means the Vx is equal to 4 meters per second. It's clear? So I am going to be writing this. Vx is equal to 4 meters per second, the findings. And similarly, we can calculate the acceleration. What is the acceleration? The rate of change of velocity with respect to the time, we can say that is going to be the acceleration. Particularly in this case, that's going to be in x direction we need to be calculated. So the same equations I am going to be using d square x by dt square is equal to, and already 4 into t plus 1 is there. So if I am going to be taking, the 4 is going to be the constant one, and the t plus 1, if I am going to be taking 4t only available. So when I am going to be doing the derivation 4t, so then I am going to be getting 1 over here. The 1 derivation is going to be 0. Then finally d square x by dt square, this I am going to say ax is equal to 4 meter per second square. I got it. Right? So on this basis, that ax is equal to 4 meter per second square I have received. Now once we are going to be find out the velocity in x and acceleration in x direction, we need to find out the velocity and acceleration in the y direction. Yes, this is the relation he has given. That is the displacement and the time relation in y direction. So now how we are going to be solving? As we know, the same procedures we are going to be applying. That's going to be dy by dt is equal to 2e2. This is going to be u to the power of minus 2. So when I am going to be doing the derivation, this is the minus 2, this is the t plus 1, minus 2, minus 1. Right? This is the derivation we are going to be getting. The finally minus 4 t plus 1 to the power of minus 3. So this is going to be, we are going to be getting the velocity. What is the velocity? Vy is equal to, right? If I am going to be substituting the value of t is equal to 0, when the t is equal to 0, so then in this case the t will become 0 and plus 1 to the power of minus 3, then finally we are going to be getting minus 4 meter per second I am going to be getting. Now we are trying to find out the acceleration in the direction of the y. So this is going to be d square y by dt square is equal to minus 4 and u to the power of minus 3 means here minus 3 t plus 1 whole to the power of minus 3 minus 1. Further simplification I am going to be getting here the result of t plus 1 minus 4. If the same I am going to be say, this is going to be the ay at t is equal to 0, so then t, and t means here is going to be 0, 1 to the power of minus 4 also we are going to be getting only the 1. So then I am going to say ay is equal to 12 meter per second square. Can you see? Vx is equal, Vy is equal to 4 meter per second, and similarly ay is equal to 12 meter per second square. So these are the findings we got. Now we need to find out the total velocity and the acceleration, and what's the direction of that resultant velocity and resultant acceleration we need to calculate. So here is the total velocity. V is equal to the square root of Vx square plus Vy square. So then I am going to be substituting in this one. That's going to be under square root of 4 square plus minus 4 whole square. And here we are going to be getting 4 means 16. 16 plus 16, that is equal to the square root of 32. So if I am going to be simplifying this equation, that's the V is equal to, I am going to be getting in meters per second. So then what's the value we are going to be getting here? So that value is equal to 5.66 meters per second. This is your total velocity. Then what is the direction? Because it is following the hyperbola, rectangular hyperbola curved path, right? So then it is not moving in the x direction, not in the y direction. This is going to be the velocity at the instant of the time. So then the direction I am going to be taking, the velocity direction I am going to be calculating by using the that is the theta is equal to, so that I am going to be taking tan theta is equal to V by Vx. So this is going to be, we are going to be getting the minus 4 by 4 we are going to be getting. So from this one I am going to be getting theta is equal to tan inverse minus 1. Okay, so then finally what is the theta value? So from this one I got the theta is equal to, so theta is equal to 45 degrees, I got it. That means this is the velocity theta. That means Vx and the Vy. Suppose we are going to be taking, this is the Vx, this is the Vy, and then it is moving in this direction 45 degrees. This is the V, this is the Vy. So then I hope you are able to understand this part. Now similarly we are calculating the total acceleration. So here is the total acceleration. A is equal to the square root of ax square plus ay square. So then I am going to be substituting in this equation. That's going to be square root of, so here the 4 square plus 12 square. So then finally a is equal to, what is the value of 4 square plus 12 square? Here is the 144 plus 60. Then finally I am going to be getting around 12.65 meter per second square. So this is the value I have received. So then once we are going to be calculating the resultant acceleration of that particle when particular instant, so then what is the total direction? That is the tan theta. This is going to be your acceleration direction we are calculating. This is going to be ay by ax. So this is going to be 12 by 4 I am going to be getting. So then theta is equal to tan inverse 3 we are going to be getting. Tan inverse 3. So then what is the value we are going to be getting here? That's going to be, so this is going to be due to the acceleration. So from this theta A is equal to, so that is going to be 71.6 degrees. I got it. Can you see the velocity we got the 45 degrees, and this one we are going to be getting 71.6 degrees. This way we are going to be calculating. I hope you people are able to understand how to find out the given conditions by using the existed data. So in this case we have taken rectangular coordinate system for identifying the velocity component as well as the acceleration component. At the same time we have found out the resultant direction of the velocity as well as the acceleration in terms of the theta and theta A we are going to be calculating. I hope you are able to understand the concepts what we are doing. If you feel any difficulty regarding this concept, and please put in the comment section so that I can reach to you. So I hope for better understanding, please follow the series of video lectures. Thank you.